What's up guys, welcome back to another video, and in this session we are going to look at how to solve linear equations. And as always, these videos, they focus really on the exercise part of things. So first we're going to line out a general strategy on how to solve these problems, and then we're going to go step by step solving such equations. Now at the start I'll be going very slowly, really outlining each step, but then along the way the exercise becomes progressively more difficult, but hopefully you will get the hang of it at that point. So linear equations, there's basically 2 points of view that you can look at linear equations. The first is the algebraic approach, which is basically just find x. And the second one is the graphical approach, where we look at the functions. But in this video, we're going to look at this first approach, which is the find x approach. I will post another video in the future where we're going to use our skills that we learned today to look at the graphical approach. So with that out of the way, let's go into the first exercise, which is just x plus 3 is equal to 0. Now, without doing any mathematics, we can already see that if x is equals to minus 3, this equation holds. And that's exactly the intuitive approach of this algebraic view of things. Basically, it says, what does x have to be in order for this equation to be true? Now, here we see very easily that x has to be minus 3, because then we get minus 3 plus 3, which is indeed equal to 0. So in this case, x is minus 3 is the obvious answer. However, when things become more difficult or complex, we want to have a strategic or systematic approach so that we can solve any linear equation, not just the easy ones. This systematic approach goes as follows. We want to get x on the left-hand side of the equation. Just as a reminder here, we know that the answer was x is equal to minus 3. So we see here that the answer consists of an x on the left-hand side of the equation and a number on the right-hand side of the equation. So how do we achieve this? Well, we just want to get all of the x expressions on the left-hand side and all of the number expressions on the right-hand side. So let's see how this goes into work. So the first step, when we start from this x plus 3 equals 0, is subtracting 3 from both sides of the equation. Because then we see x plus 3 minus 3 is equals to 0 minus 3. So this just very easily becomes x is equal to minus 3, because this plus 3 minus 3, they cancel each other out. So, well, here we already have our answer. X is minus 3. There you go. So that's the systematic approach of how to solve these linear equations. Let's look at the second exercise. 3x plus 3 is equal to 0. Now, what does this 3x means? So 3x just is 3 times x, or in other words, it's x plus x plus x. So what do we do now in this situation? Again, we want to get the x on the left-hand side of the equation, and we want to get all of the numbers on the right-hand side of the equation. So how can we achieve this? Well, the first step, again, is getting all of the numbers without an x away from the left-hand side. Again, this is achieved by subtracting 3 on both sides of the equation. So we get 3x plus 3 minus 3 is equal to 0 minus 3. This basically simply becomes 3x plus 3 minus 3 cancel each other out, so it's 0, is minus 3. So now we have 3 times x is minus 3. How do we get this 3 in front of the x? How do we get it, well, away? Because we just want an answer where we have on the left-hand side of the equality sign x and on the right-hand side a number. So this 3, we can just divide it away, because as a reminder, this 3x is just 3 times x. So if we divide 3 times x by 3, then we just get x. So let's do this. So we divide both sides by 3, which means that we have 3x divided by 3 equals minus 3 divided by 3. If we rewrite this, we get x is equal to minus 1, because this 3 and this 3 cancels, and this 3 and this 3 just becomes minus 1. And there we have our answer. X is equal to minus 1. What's always a good idea to do at this point is to see if we didn't make any mistakes. So how do we do this? Well, simply by substituting our answer into the original equation, the original problem that we had. Because as a reminder, this problem simply stated that for what x is this equation true? Well, we found an x, namely x is equal to minus 1. So let's see if we didn't make any mistakes. So we have 3 times, and for x, we just substitute our answer, minus 1 plus 3 should be equal to 0. Well, this is the case, because we have minus 3 plus 3, which is indeed equal to 0. So we didn't make any mistakes. Let's look at the next exercise. 5x minus 8 is equal to 0. Again, the basic question is, what number does x have to be in order for this equation to be true? Well, again, we want to have everything x on the left-hand side of the equation and all of the numbers on the right-hand side of the equation. Again, we start with the basic numbers, which is this 8. We want to get rid of it on the left-hand side. So we add 8 on both sides of the equation. We just get 5x minus 8 plus 8 is equal to 0 plus 8. Rewriting this is 5x minus 8 plus 8 is equal to 0. On the right-hand side, we get 8. Now again, we face a problem that this 5 in front of x, which is basically just saying 5 times x, we want to get rid of it. And in the same fashion as before, we just divide both sides by this number, by 5. So we get that 5x divided by 5 is equal to 8 divided by 5. Rewriting this, we get x is equal to 8 divided by 5, because this 5 and this 5 cancels out, and well, this is just a fraction that we copy. So we have our answer, and as should be a good practice, we check if we made any mistakes. So we again substitute this in our original problem, which then gives 5 times x will be substituted by 5 divided by 8, 8 divided by 5, minus 8, and this should be 0. Is this 0 indeed? Well, yes, because this 5 cancels out. So we just get 8 minus 8 is indeed equal to 0. So we didn't make any mistakes. Let's go to the next exercise, which is 3x minus 5 is equal to 7. So now the only difference with the previous exercise is that we don't have this 0 on the right hand side. But well, that's no problem. We just use the same strategy as always. We want to get all of the x's on this side of the equation and all of the numbers on that side of the equation, because only in this way we get x is equal to some number. So what we do, it's just very simple. The first thing we do is get this 5 away from the left-hand side of the equation. This is done by adding 5 on both sides of the equation. And again, the same strategy as always can be carried out and will eventually yield the right result. So here we get 7 plus 5. Rewriting this, we get 3x minus 5 plus 5 is equal to 0. And on the right hand side, we get 7 plus 5 is equal to 12. So now again, we have to get rid of this 3 in front of the x. This can again be done by dividing both sides by the number in front of x, 3 in this case. So we get 3x divided by 3 is equal to 12 divided by 3. And this yields our answer directly, which is x is equal to 4. Quite straightforward, right? So now again, to see if we made any mistakes, we substitute x is equal to 4 in our original equation, which is here. And we see if we indeed get, well, an equality. Okay, so let's do this. 3 times x is equal to 4 minus 5 should be equal, we don't know that yet, to 7. If we didn't make any mistakes, this should indeed be equal to 7. So 3 times 4 is 12 minus 5 is equal to 7. Well, yes, 12 minus 5 is equal to 7, so we didn't make any mistakes. So again, here we just used the basic strategy of putting all of the x's on one hand side of the equation and all of the numbers on the other side of the equation. So let's step it up a notch. We have x minus 7 is equal to 3x. Now, this equation looks a bit different than the previous ones because we have an x on the right-hand side of the equation and an x on the left-hand side of the equation. But this should not bother us because we just have to follow the systematic approach of having all of the x's on the left-hand side of the equation and all of the numbers on the right-hand side of the equation. So first, what we can do is get rid of this 7 here, this minus 7. We want to get this minus 7 on the right-hand side of the equation. This we can do as in all the previous exercises by adding 7 to both sides of the equation. So we get x minus 7 plus 7 is equal to 3x plus 7. Rewriting this, we get x, and this minus 7 plus 7 is equal to 0, is equal to 3x plus 7. So at this point, we want to get this 3x on the left-hand side of the equation. So how do we do that? Well, we just have to remember that 3x is basically just x plus x plus x. It's 3 x's. So we can do the same as we did here by adding or subtracting, in this case, 3x on both sides of the equation. So that should get rid of this 3x on this right-hand side of the equation. So let's see what this becomes. Minus 3x on the left-hand side of the equation is 3x plus 7 minus 3x on the right-hand side of the equation. So what does this become if we rewrite this? So it basically becomes x minus 3x is equal to 3x plus 7 minus 3x. Okay, I just copied it, but now without color. But let's look now at this 3x minus 3x. It's just the same number. You shouldn't be thrown off guard by there being an x here, because what this basically means is 3x minus 3x is basically x plus x, which is from this one, minus x minus x minus x, which comes from these ones. And this is just 0. So this one becomes 0. So we get 7 on this side of the equation, which is exactly what we wanted. Now, on the left-hand side of the equation, we have x minus 3x, which is basically x minus 3x is x minus x minus x minus x, is these two cancel out, minus 2x. So we get minus 2x on this side of the equation. So what we did here, from this step to this step, we basically got this 3x on this side, we got it to the other side. And then we just, well, did some algebra to get the result minus 2x is equal to 7. Now we are at the point that we are familiar with. Just a number in front of an x is equal to a number. We can get rid of this number in front of the x by just dividing by this number. So we divide by minus 2. So let's see what this becomes. Minus 2x divided by minus 2 is equal to 7 divided by minus 2, which then, when we rewrite it, easily becomes this minus 2 and minus 2 cancels out. X is equal to minus 7 over 2. And there we have our result of this somewhat more complicated example. And as always, we can very easily check this by substituting our answer that we found back into our original equation and see if it indeed is an equality sign, if it is indeed a true statement. So let's do this. So first we have the x here. Well, we know that x is equal to minus 7 over 2, so we get minus 7 over 2. Then we have minus 7, okay, minus 7, equality sign, and then the 3 times x. So that would be 3 times, oops, so that's in black, 3 times x is minus 7 over 2. And we want to know if this is indeed an equality sign. Let's see if this is indeed the case. So we get minus 7 over 2, minus 14 over 2, just putting it on equal denominators. Is this equal to minus 21 over 2? Because this 3 gets multiplied by this minus 7, which is minus 21. Is this indeed the case? So minus 7 minus 14. Well, let me just write it out fully so we don't get any confusion. Is this indeed the case? Well, yes, because minus 7 minus 14 is minus 21 divided by 2, and this is indeed minus 21 divided by 2. So we didn't make any mistakes, and our answer is x is minus 7 over 2. And just not to lose track of the meaning of this, this means that if we, in this equation, this original equation, fill in x is minus 7 over 2, that this equality sign is indeed correct. So that's the meaning. So that was the meaning all of the time. So we had to find an x in such a way that these original equations are true. So let's go to the next and probably final exercise, which is 3 divided by 2x minus 5 is equal to x. So this is probably the most difficult form of these kind of exercises that you will find. However, if you just follow the systematic approach of getting all of the x on the left-hand side of the equation and all of the numbers on the right-hand side of the equation, we just should get the right result. So let's start off. So the first thing we have to do is get this minus 5 on the right-hand side of the equation. And as always, we can do this by adding 5 to both sides of the equation. So that would be 3 divided by 2 times x minus 5 plus 5 is equal to x plus 5. All right. Writing this out, 3 divided by 2x minus 5 plus 5 is equal to 0. And on the right hand side, we just get x plus 5. All right, so now we get this x here, which is on the right hand side, and we don't want it there. We want it to be on the left hand side. This can be very easily done by simply subtracting x on both sides of the equality sign. So we get 3 divided by 2 times x minus x is equal to x plus 5 minus x. Here we see that if we rewrite this, we get 3 over 2 times x minus x is equal to x minus x is 0. They cancel each other out. So only this 5 is left on the right hand side of the equation. So we're almost there. We just have to, well, write this as 1x. And this is simply, well, let me just write it out fully. Is 3 halves minus 1 times x is equal to 5, because x is in both of these expressions here, which is equal to 3 halves minus 2 halves times x is equal to 5. I'm really writing this out now, which is equal to 3 minus 2 divided by 2 times x is equal to 5. And we get our final answer because we just get 1/2 x is equal to 5. Now, as a last step, we want to have only x here. So we want to get rid of this 1/2 in front of the x. This can be easily done, as we've seen multiple times now, by dividing both sides by the factor in front of the x. So divided by 1/2. And then we should get our result. So we get 1/2 x divided by 1/2 is equal to, oops, I should use black, 5 divided by 1/2. And if we rewrite this, well, this 1/2 and this 1/2 cancels out. So we just get x is equal to 5 divided by 1/2 is 5 times 2, because this 2, well, it goes there because it's in the denominator of the denominator, so it becomes the numerator. So we simply get that x is equal to 10. And there we have our final answer of this, well, on first sight, difficult problem. So as a final check of this video, to see whether we made any mistakes in this rather large calculation, is to fill in this result that we had, x is 10, in our original equation to see whether we didn't make any mistakes. So we have 3 halves times x. So we get 3/2 times, and x is 10, minus 5, and this should be equal to, if we didn't make any mistakes, 2x, and we know that x is equal to 10. So is this equal to, oh, I should use right color scheme, is this equal to 10? Let's see if it is. So we get 30 divided by 2 minus 5, is this equal to 10? Well, this is starting to look very good, because it's 15 minus 5, is this equal to 10? And of course, it is. 10 is equal to 10. We didn't make any mistakes, and we aced our problem. So that's basically the way you should go about solving these problems. You first want to get all of the x expressions on the left-hand side of the equation and all of the number expressions on the right-hand side of the equation, and then just try to get the answer by basic algebraic expressions all the way to having x is equal to whatever number. And it's very important in these exercises not to lose track of what you're doing. For example, here, what you're doing is you want to find x in such a way that this equality sign is true, such that this is a true statement. And in that sense, having our systematic approach, this last exercise should be as easy as our very first exercise, where we could just, well, see the answer right away. So with that, I would like to thank you for listening. I hope you learned something. And if you have any questions about any of the exercises that we covered here, please let me know in the comments. At this point, I still read all of the comments and I will reply to all of the comments. And if you have any suggestions of other topics that I should do in the future, just let me know. So with that, have a nice day and happy learning.